One of the big things that is happening right now is that people have intense faith in the modern cosmological models of the nature of the universe, the origins of the universe, etc., etc. I would actually like to assert, and I know this annoys hardcore scientists, but let's address the fact that modern cosmological models maybe have deepened our ignorance and added more mystery to the origins and nature of the universe. I know that modern cosmology has made remarkable strides in explaining the structure and evolution of the universe, but it has also introduced profound uncertainties that challenge its very foundations. While scientific progress often leads to new questions, the current cosmological models seem to have created more confusion than clarity. And they have exposed gaps in our understanding that they are so vast that they verge on philosophical mysteries. The Big Bang Theory, cosmic inflation, dark energy, and the incompatibility of quantum mechanics with general relativity are just a few examples of how our attempts to understand the universe have led us into deeper realms of ignorance. So let's look at all these. The Big Bang Theory is widely accepted as the most accurate model for the universe's origin. Yet it fails to address one of the most fundamental questions: what caused the Big Bang? The theory describes how the universe expanded from an initial singularity, but offers no explanation for why this event occurred or what existed before it. In fact, the laws of physics themselves break down at the singularity, leaving us with no framework to even ask meaningful questions about causality. Instead of providing clarity about the universe's beginnings, the Big Bang Theory has introduced a conceptual void, a moment where science itself seems to falter. This has not only deepened the mystery of our origins, but also highlighted a fundamental limitation in our understanding of time, space, and causality. Then there is the mystery of the Planck Epoch, a period beyond physics. The Planck Epoch represents the earliest moments after the Big Bang, 10 to the power of minus 43 seconds. It's another source of profound confusion. During this time, conditions were so extreme that none of our current physical theories, neither general relativity nor quantum mechanics, can describe what happened. This period marks a complete breakdown of our scientific models. The inability to reconcile gravity with quantum mechanics means we lack even a theoretical framework for our understanding of this critical moment in cosmic history. Far from solving mysteries about the universe's origins, modern cosmology has exposed a fundamental gap in our knowledge that seems insurmountable without an entirely new physics. Cosmic inflation, which is an elegant but unexplainable solution. Cosmic inflation, the rapid exponential expansion of the universe moments after the Big Bang, is another example of how modern cosmology has increased uncertainty. While inflationary theory elegantly explains phenomena like the uniformity of cosmic microwave background radiation and the flatness problem, it raises more questions than it answers. What caused inflation? Why did it stop? Why does it appear so finely tuned to produce a universe capable of supporting life and coming up with this argument? These questions remain unanswered despite decades of research. Inflation theory solves some potential problems, but introduces others that seem even more perplexing. It replaces one mystery, the Big Bang singularity, with another equally enigmatic process. And here's the big one, the cosmological constant, a crisis in physics. Perhaps one of the most glaring examples of confusion in modern cosmology is the cosmological constant problem. Observations show that dark energy, a mysterious force driving the accelerated expansion of the universe, exists, yet its measured value is vastly different from theoretical predictions. Quantum field theory predicts a value for dark energy that is 120 times orders of magnitude larger than we observe. This discrepancy has been called the worst prediction in physics and underscores a fundamental misunderstanding of how quantum mechanics interacts with general relativity. Instead of clarifying our understanding of the universe's expansion, this issue has exposed a crisis in physics that suggests our current theories are fundamentally incomplete. Then, of course, gravity versus quantum mechanics, which seems to be an irreconcilable divide. The incompatibility between general relativity and quantum mechanics represents the most profound failure of modern cosmology. General relativity describes gravity on large scales, while quantum mechanics governs subatomic particles. Yet these two pillars of modern physics cannot be unified into a single framework. This incompatibility becomes particularly problematic in extreme environments like black holes or during the early moments of the universe when both theories should apply simultaneously. The lack of a theory of quantum gravity not only limits our understanding, but also highlights a glaring inconsistency at the heart of modern physics. Then, of course, dark matter and dark energy, mysteries that define our universe. Adding to this confusion is the realization that 95% of the universe consists of dark matter and dark energy, entities that remain entirely mysterious despite their overwhelming influence on cosmic behavior. Dark matter is inferred from its gravitational effects but has never been directly observed or identified. Dark energy is even more enigmatic, representing a force that defies explanation, existing within physical theories. These discoveries have shifted our perspective from believing we understood much more about the universe to realizing we understand almost nothing about its composition. And then there's something called baryon asymmetry, a universe out of balance. Another unresolved issue is baryon asymmetry, the observed dominance of matter over antimatter in the universe. According to current theories, matter and antimatter should have been created in equal amounts during the Big Bang and annihilated each other completely. Yet, matter dominates today, allowing galaxies, stars, planets, and life to exist. This imbalance remains unexplained and challenges our understanding of fundamental physics. So, while modern cosmology has provided remarkable insights into certain aspects of the universe, such as its large scale structure and evolution, it has simultaneously deepened many mysteries about its origin and nature. This inability to explain foundational aspects like the cause of the Big Bang or reconcile gravity with quantum mechanics suggests that our current models are incomplete at best and fundamentally flawed at worst. Far from reducing ignorance, these models have revealed vast gaps in our understanding that seem to grow larger as we probe deeper into cosmic phenomenon. In many ways, modern cosmology has replaced old mysteries with new ones, mysteries that are arguably more perplexing because they expose limitations not just in specific theories, but in our entire scientific framework for understanding reality. As we continue to explore these questions, we may need entirely new paradigms to make sense of a universe that remains as enigmatic as ever. So, a message from Rumi to modern scientists: exchange your cleverness for bewilderment, because bewilderment is holy. Okay, friends, this is the book I'm promoting right now, How AI Can Elevate Spiritual Intelligence and Personal Well-Being. And if you want to continue to engage with me, you can also do so by checking out deepakchopra.ai. And thank you for always indulging my crazy reflections.